Hi everyone. Now let's discuss topic 3 of Unit 4, computer equipment and associated storage media. In digital forensics, computer equipment and storage media are crucial sources of evidence. Storage devices contain digital footprints such as files, logs, and system data, which can be recovered even after deletion. Storage media is broadly classified into volatile and non-volatile types. Volatile storage, for example, RAM, loses its content when power is turned off. Non-volatile storage, for example, hard drives, SSDs, flash drives, retains data even without power. Removable storage, devices like USB drives, CDs, DVDs, and external hard disks are common in investigations, but also risky, as they can be easily tampered with or used to spread malware. Handling seized devices must be done with extreme care, using right blockers, anti-static bags, and proper chain of custody procedures to ensure evidence integrity. To make this clear, let's look at some exam-focused questions. 2-mark questions. What is the role of storage media in digital forensics? Give 2 examples of removable storage devices. What is volatile storage? Name any 2 non-volatile storage devices. Why is it important to handle seized storage devices carefully in forensics? 5-mark questions. Explain the classification of computer storage media used in forensics. Differentiate between volatile and non-volatile storage with examples. What are the precautions to be taken while handling seized storage media? Write a short note on removable storage devices and their forensic significance. Explain the role of computer hardware components in cyber forensic investigations. In digital forensics, computer equipment and storage media are critical because they often contain evidence related to cybercrimes. Investigators must carefully identify, secure, and examine these devices to ensure that the data remains unaltered and legally admissible. Mishandling these components can compromise the investigation and weaken the evidence in court. Categories of computer equipment. Input devices. These include keyboards, mice, scanners, and other devices used to interact with computers. Although they may not store large amounts of data, they can leave traces, such as keystrokes captured by keyloggers. For example, if an insider fraud case is being investigated, forensic analysis might focus on detecting illegal keylogging software installed on the keyboard input interface to capture confidential data. Output devices, devices like printers, monitors, and plotters can sometimes provide evidence. Printer logs, for instance, can show who printed sensitive documents and when. For example, in a corporate leak investigation, printer logs could reveal if a confidential report was printed without authorization. Processing units, CPUs, motherboards, and internal firmware may contain crucial evidence. System memory, cache, and firmware settings can reveal malware execution, system configurations, or unauthorized access. For example, analyzing a motherboard's firmware could uncover rootkits installed to hide malicious activity. Networking equipment, routers, switches, firewalls, and access points store logs, configurations, and routing information that can be invaluable in tracing cyberattacks. For example, firewall logs can help investigators track unauthorized data transfers or determine the source IP of an external attacker. By understanding these categories, forensic investigators can systematically approach evidence collection, ensuring that all potential sources of relevant data are preserved and analyzed. This methodical approach increases the chances of building a strong legal case while maintaining the integrity of the evidence. In digital forensics, understanding storage media types is essential because different media hold different kinds of evidence and require specific acquisition techniques. Storage media can be broadly classified into primary, volatile, memory, and secondary, non-volatile storage. Primary storage, volatile memory. Volatile memory temporarily holds data and is lost when the device loses power, so investigators must capture it while the system is running using live forensics tools. RAM, random access memory, stores information about currently running programs and processes. For example, if a hacker has just accessed confidential files, RAM may contain traces of their activity before they are saved to disk. Cache memory, a high-speed storage area for frequently used data, can also reveal evidence of recently executed applications or web sessions. Live acquisition tools like Volatility Framework or Belkasoft Live RAM Capturer are used to extract this data without altering the system. Secondary storage, non-volatile memory. Non-volatile storage retains data even when the device is turned off, making it the primary source of forensic evidence. Common types include hard disk drives, HDD, magnetic storage devices with large capacity, often containing operating systems, documents and logs. For instance, in an intellectual property theft case, investigators may find stolen files on an HDD. Solid-state drives, SSD, flash-based storage that is faster and more resilient to physical shock. For example, a suspect's SSD could reveal deleted emails or application logs. Optical discs, CDs, DVDs, Blu-ray, used for storing backups or transferring data. In a corporate fraud case, a burned DVD could contain sensitive financial records. USB flash drives and memory cards, portable and frequently used for data transfer. For example, a USB drive left in an office could contain malware or unauthorized copies of confidential files. By identifying the type of storage media, forensic investigators can choose the right tools and techniques for acquiring, preserving, and analyzing evidence. This ensures that crucial data is not lost, altered, or overlooked, which is vital for building a strong legal case. In digital forensics, storage media are classified into removable and fixed storage, each requiring different handling techniques due to how evidence may be stored and accessed. Removable storage. These are portable media that can easily be connected or disconnected from a computer. Common examples include USB drives, SD cards, and external hard disks. Removable storage is often involved in data exfiltration or unauthorized transfers, such as an employee copying confidential documents to a USB drive to take home or sell. Investigators must carefully document and preserve these devices, as they can contain critical evidence of insider threats, malware distribution, or intellectual property theft. Fixed storage. This includes built-in hard drives, HDDs, and solid-state drives, SSDs, inside desktops, laptops, and servers. Fixed storage is typically the main repository for operating systems, application data, logs, and user files. For example, in a cybercrime investigation, a suspect's laptop, SSD may hold emails, browsing history, or malware artifacts that reveal illegal activities. Associated storage media. Forensic investigations may also involve other types of storage. Magnetic tapes, traditionally used for backups, which can contain historical data critical for reconstructing events. Cloud storage. Services like Google Drive or AWS S3 require remote acquisition techniques, such as secure API extraction or legal warrants, because data is not physically present. Hybrid drives, SSHD. These combine SSD speed with HDD capacity, and evidence may reside in either the flash cache or the magnetic disk. Forensic handling precautions. To maintain the integrity of evidence, investigators must follow strict procedures. Use write blockers to prevent accidental changes to the data when connecting the storage to analysis tools. Document every step with a chain of custody, ensuring the evidence can be legally presented in court. Avoid booting the suspect's system, as this can overwrite volatile memory or hidden files. Store devices in anti-static, tamper-evident bags to protect against physical damage or unauthorized access. By carefully distinguishing between removable and fixed storage and following proper forensic handling, investigators can ensure that digital evidence remains admissible, intact, and reliable, which is crucial for solving cybercrime cases and supporting legal proceedings. Storage media play a critical role in digital forensics because they hold the evidence investigators need to understand, reconstruct, and prove what happened during a cybercrime or security incident. They contain both direct and indirect evidence. Direct evidence. This includes the actual content stored on the media, such as files, emails, documents, images, videos, or system logs. For example, a suspect's USB drive may contain stolen company documents, or a hard drive might have ransomware scripts that were used in an attack. These pieces of evidence can directly link a person to illegal activities. Indirect evidence. This refers to metadata, timestamps, access logs, and system information that reveal how and when actions occurred. For instance, file metadata might show that a confidential document was accessed at 2 a.m. Or system logs could indicate repeated login attempts from an unauthorized user. Even deleted files can often be recovered and provide clues about an attacker's behavior. Legal admissibility. Proper handling of storage media is crucial to ensure that evidence is accepted in court. Investigators use write blockers, maintain a chain of custody, and document every step to avoid accusations of tampering. For example, if a seized hard drive is analyzed without following these procedures, a court may reject the evidence, weakening the case. Reconstructing events. By examining storage media carefully, forensic analysts can piece together a timeline of events. For example, analyzing a suspect's laptop and email logs could reveal how a phishing attack was executed, what files were exfiltrated, and which accounts were compromised. In summary, storage media are the foundation of digital investigations, providing both the factual content and contextual information needed to solve cybercrimes, identify perpetrators, and support legal proceedings. Thank you. Please like, share, and subscribe.